Hey my colleagues, welcome back to Softwaring. Today came back with another ansys tutorial on how can you do transient analysis by using workbench. So as you know, the problem description is explicitly given to you. So as you see from the problem, the time varying load is given within some time range, and also the geometry or the diagram is given. So as you see from the diagram, this roller is rolled over this bridge-like structure. So in this sense, we assume that this roller is passing over on those 5 faces. So since this is rolling on those surface, so the location or the point of the force action will be varied through time. So as you see from the problem description, considering a roller moving on a bridge-like structure shown in the figure below, which is made of a structural steel, for the top surface of the structure is equally divided into five faces. The loading condition as the roller over the face in time versus force record are given in the table below. We will conduct a transient structural analysis to determine the total deformations, the volume stress, even the life and the factor of safety of this bridge. So let's assume the bottom surface of the legs and the in face of the structure are assumed to be fixed. So in this particular video, I'm gonna show you how can you do this transient analysis step by step. Keep watching. To start with, let us open our ansys workbench. So from ansys workbench, let us double click on the transient structural. The project schematic window will appear like this. So first let us adjust our engineering data or the material of this structure. So the material of this structure is structural steel, and ansys workbench accept this material as a default. So let us put this to the project, and then let us double click on the geometry. The ansys workbench or the design model will appear like this. So to start with our sketch, let us adjust our unit first. So millimeter is our unit. So let us select one plane and make it look at face, and then let us start our sketch. Let us create then let us modify. Let us trim this part, and then let us apply some constraints like equal length because of its symmetry. Yes, then let us dimension it. So this is 500 millimeter, and this is 125 millimeter, and this is 25 millimeter. Again, this is 50 millimeter, and this is 100 millimeter. Once we create this sketch, let us generate it, and then let us extrude this 100 meters. Then if you generate this, you will get our sketch. So this is our bridge-like structure. So let us select the upper face and let us sketch let us sketch rectangles here. And then let us dimension it. Then let us extrude those faces. Let us select all the 5 faces, and then from here operation, let us select imprint faces. Then if you generate this, you will get 5 different surfaces of the upper face of the bridge. So we finished what we have do on the design modular. So let us close this and proceed to the next step, which is the model. So double click on the model. Then on workbench will open like this. So to start with, let us accept the default mesh setting. So let us generate mesh. Then from the transient or F5 tree of the project, let us click and insert fixed support. So as this face, again those 2 faces, and this face, then apply. So we fix all those 4 faces. Then from the analysis setting, let us adjust the initial time step. Let's assume the first time step is 0.1 and the minimum time step is 0.1, then the maximum will be 0.7. So in this analysis, let us apply the force on the transient force on this face. Then the magnitude is in tabular form. And then the direction is in the downward direction. Then apply, and then let us apply the second transient load on the second face, on this face. Apply, then the direction is in the downward direction. Let us change it. Apply. Then let us apply the force on the third face. Then the direction is in the downward direction, so this arrow shows that the force is in the downward direction. Then let's apply. Similarly, let us apply the force again on the fourth face. Apply. So the direction is in the downward. Similarly, then the last and the fifth force on the fifth face is applied. Once the transient force is applied on the 5 faces, later from the solution stage, let us insert the total deformation and the Brunmeister stress, the equivalent stress, and then from fatigue tool, let us add the fatigue tool here. From the fatigue tool, let us insert the life, and also from here we can insert again the factor of safety. So if you solve this, we can get all the required results. So if you want to see the total deformation, it will be maximum at the center. So if you want to animate with true scale, so this is how this bridge is deformed. So the red section is the maximum deformation, the place where maximum deformation is happened. So the magnitude is 9 times 10 to the power of minus 8 units. So it's a very small diffraction, but it's compared to the others, it's somewhat more deformed. So if you want to the equivalent stress or the Brunmeister stress, so the distribution will be like this. So it is distributed over the surface because the transient load is varying from this right in to the left with when time vary. And so if you want to see the total life, if this force is fully reversed, so the minimum life will be 1 times 10 to the power of 6 cycles, or around 1,000,000 cycles. And also under those loading conditions, the factor of safety will be 15 as somewhere, and it's also greater than 50. So this design is over designed. So this is how can you do a transient analysis by using a workbench. I hope this is helpful for you. So if you think it is interesting, or if it make any sense for you, please subscribe my channel. For today, this is what I have. So thank you. Thanks for watching me.